Hi everybody. Over the past week I've been gradually taking apart a bunch of tablet PCs, HP tablet PCs, specifically the Compaq 2710P, and I've been trying to get all the LCD backlight panels, and you can see right here that it is quite bright. It's got a whole bunch of LEDs down here in this bottom strip, and then very thin plastic sheet diffusing the light, and of course there are some other layers on there too. Got these other diffusers here, and behind the plastic backlight was these mylar, very reflective, highly reflective mirror finish mylar mirrors. Very nice. All that stuff might come in handy someday, but for the moment I have a project in mind for these LED backlight panels, and that is to make a chandelier out of them. Something like this, if you're down on the floor looking up. And I was thinking of having an octagon structure like this hanging from the ceiling, and then 8 of these individual plastic panels hanging from each side of the octagon, and of course they'd all be individually lighted. And I was thinking that I could run them all steady state all at the same time, or if I really want to go all out, maybe I could put an Arduino or something, some kind of microcontroller on these things so they can alternate in various ways, make funky patterns, you know, for parties or whatever. You know, it'd be good to have some flashing lights going on. And what's really nice about these things is that it has individual control of each half. So let me take that out. So there's the left half of the panel lit up, and there's the right half. Just with how the LEDs are wired internally, I have individual control of one half or the other half. So that leaves lots of potential for making all kinds of really funky patterns on the finished chandelier. But unfortunately, I ran into a potential problem that would limit the completion of this for another couple of months at least, because I want to characterize the LEDs to make sure that they're actually going to last long enough to actually warrant themselves viable for being in a chandelier or any kind of room lighting environment. I want to make sure that they last long enough. Now, I looked up, here I have a strip of LEDs already lit up, and I looked up online trying to find all kinds of white LEDs that would match just, you know, what I see on them. There's no part number, of course, on them, and, you know, no part number on the LED strip itself. By the way, this LED strip is what's inside of the metal strip right here. So just peel apart the metal base, and then this is what's left over behind on the inside. And there is 12 LEDs in 4 individual series strands. So that's a total of 48 LEDs for this whole thing, and 12 LEDs. I can run them all in parallel, and that's what I have going on right here for a life test of these LEDs, running at, for each branch I got them going at different currents, and I want to see just how long they actually last. Alright, so I just unplugged it for a minute here so we can see the individual LEDs, and you can see how they alternate one after another. There's that one in series with that one, in series with that one, in series with that one, and so forth. And then the same thing for the other ones. If that's odd numbered and that's even numbered, all the even numbered ones are in series with each other. And that is the case for one half of this whole strip, 24 LEDs down the row until we get to right here. Then there's another set of 24, again alternating series of two branches with alternating LEDs, and they all go back down the flat flex strip, and I have a little converter right here going to resistors and then going into this contraption, which is just a couple of Phoenix contact power supplies, 24 volts each, and in series for 48 volts, and then resistors to limit the current in the individual branches to a number of milliamps per branch. And let me plug it back in. So right here, these LEDs that are lit up very, very brightly, those are all 20 milliamp going through those. The ones in between, which aren't lit up at all, that's effectively 0 milliamp. I have a 1 megohm resistor in series with them anyway, which I measured earlier is like 0.02 milliamp, 20 microamp. So effectively they're turned off. And then alternating here, I guess you can make out the brighter ones and the dimmer ones. That would be 10 milliamp and 5 milliamp respectively going through these LEDs. And so I'm going to just leave these plugged in somewhere and leave this whole thing turned on continuously for at least 1,000 hours, which is going to be about a month and a half. And I just want to do this to give a good life test to these LEDs to see if I can actually viably make a good quality chandelier or any kind of light source that's going to last for a long time and still have the LEDs working just fine and without dimming over time. I don't want to, spend a whole lot of time making this fancy chandelier, putting all kinds of hours into it, and then discovering that after 1 or 2 months of use that the LEDs just aren't as bright as they used to be. So that's the whole purpose for this. Even though I'm pretty confident that these are 20 milliamp LEDs, I did do some research on DigiKey, looking at different LEDs to match these, or at least in appearance they look pretty similar, and those are rated for 20 milliamp. But as far as life expectancy, couldn't find very much data on that. So I'm going to have my own life expectancy test, 1,000 hours, and we'll see how it goes. So you probably won't see anything like this until next year, 2015. See you later.